Hello guys, we are back with another Leetcode challenge. Let's see the today's challenge, and the today's challenge is recover binary search string. This question is fall into the category of medium and it's the highly liked. So it's a must do question. You must try this question. So let's deep dive into the question. What actually question asks. So you have a given and root of the binary search tree where the value of exactly two node of the tree was swapped by mistakes. Recover the tree without changing instruction. So the question is pretty much straightforward. uh, you are creating the BST, but unfortunately by mistake two nodes value may be um, changed. So what should you do? You have to just change swap these two nodes and return the true tree as it is. So let's understand little bit more with using example 1. So you are wanting to create a BST, but unfortunately you create a binary tree. So you have to just convert into the BST. If you want to convert the BST, so BST have the property the left part of the root left part from the root is maybe it must be lesser than the root value, and the sub right part it must be greater than the root value. If this property is if this property is not violating, so it's called PST. So in that case you see this 3 is bigger than this one, it means it violate the property. So we just swap these two values and we got a binary search tree. Here you see this this one is lesser than, and this 2 is also lesser than this 3, and this one is a lesser than this 2 because 2 is the right of this one. So that's pretty much about, and I think you understand. Let's little bit understand more for your clearance with using the example 2. Here you see this one is less than 3, yeah, it's valid. This 4 is greater than 3, valid. But here you see this 3 is greater than this 2, but it may be not possible because if it's a BST, so all the value of this uh, root is greater than, but in that case not. So we are going to just swap these two values and return the tree. So now it's a BST because it's not violating the case. So that's pretty much straightforward. Let's deep dive into the code what actually trying to do. So we are actually I remember one property of the binary search tree, and it's a very important. If we traverse a BST in an ordered way, so we if we store the all values into the vector and traverse into the in order fashion, we got a sorted array, a sorted vector. So what is actually indicate? It's indicate if it's a BST, it must present a sorted. It must be present in the sorted. So we just take this. We just going to take this advantage. So, and if it's not a sorted, so I know there is some value, and can I do? I'll just take the root values into the vector. Okay. After doing that, I'll just sort the vector by one, and after that I'll just replace all the root value to this vector's value, and that's it. It's my BST, it's converted. So let's write guys code there. So I'll just call it in order, and in order I'll just pass it root, and what it actually does, it is actually stored into the vector, but I don't here I not make a vector. Let's make a vector globally for our sake of this, otherwise we are going to pass vector again and again. So in order, after that I'll assume this in order actually fill the all the nodes value into this v. After doing that, what's my duty? I have to sort this v, because I know this is not a val, it's violating the bst property, so I'll just sort it. And after sorting, I call another stub function. What it actually does, it actually swap this value. So I'll just name it arrange, which is going to arrange the roots value. And because we don't want to change its structure, that's why I'll just do that. So arrange what? Arrange this tree again, and that's it. That's my code, guys. But let's complete our stub function in order and arrange. So my let's complete in order first, and in order it's actually no return type, so that's why I'll just write it in order void, and it's take only one parameter, is a root. Tree node is taking one parameter, is only root. And I know how can we traverse in the in order fashion. First and foremost, we have to check is it null or not. If it's null, we are going to return from here. Otherwise, what we are going to do, we just call it left to the root. So go to the left root left, and after that do some operation on the root value. So we just going to add it into the my vector. So root val. After adding this, after doing the work on the root, we have to move on onto the right side. So on root right, that's it. This is my in order, and it actually store all the values into the my this vector v. So after doing that, I'll just sort it, and after sort it, what's my duty? I have to arrange again. So for arranging, I know if doing a same thing like in order, traversing from first left, then root, then right, it's taken advantage. I can easily build my bst. Let's see how I can build my bst. So it's again a void type, because I don't want to return anything. Tree node star root, it going to take again same thing. If root is equal to null, root equal to null, in that case I'm returning from here, no need to go ahead. And I call my arrange function. Why I'm calling? Because I'll just doing the same thing like in order traversal. I'll just go to the left. Why I'm going to left, and be tell you after some time. Go to the left. After going to left, what I'm going to do, I'll just change the root val to the v pose position. Actually I have to make a value position, which actually what do root val, first root val is actually what, it's at most left element a node in the tree. And let's complete our pose function first. It's initialized with the 0, because my vector will be started from the 0, so that's why I'll just start it from the 0. And here what's my duty, I'll just add a pose plus plus. What I here actually does, uh, I have to swap the root value to the v pose value, because I know this v pose actually sorted, and this may be violate the case our root val. So that's why I'll just uh, push all the push replace the all the values of the root from this v pose, and it's make my tree in converted into the bst. And after doing that, we have to go right right of the root. So just move on to the root right, and that's it, guys. So I think it's fine. Let's run this code. Yeah, let's submit this code, guys, and it's accepted. So if you have any doubt in this code section, let me know in the comment section. I resolve your doubt as soon as possible. Until then, keep grinding, guys, and stay tuned.